Okay. Hello, everyone. I'm your moderator now in here. My name is Melissa Krisnawati, and I will introduce you to our session talk 5 now. We have Mas Arief Rahmansyah. He is a machine learning engineer working on machine learning platform to democratize machine learning across organizations, enabling machine learning power solutions and driving business impact. Please welcome Arief Rahmansyah. The stage is
Hello
yours,
guys.
Mas.
Oh, okay, cool. Thank you, Melissa, for the introductions. Hey guys, I'm Arief Rahmansyah, and like Melissa said, I'm a machine learning engineer at Gojek Singapore, where my main focus area are deploying and scaling machine learning across organization, so it can help
Sorry,
Gojek.
Mr. Arief.
Yeah,
I
can you
cannot.
hear me?
I still cannot hear your voice in
Oh,
here.
sorry. Uh, how about
Oh,
now?
sorry,
Hello?
sorry. My volume. Okay,
Can you guys hear me?
okay, continue it, Mr. Arief. Sorry.
Okay, cool. Let me share my screen as well. Hmm. Okay, my entire application window. This one. All right, cool. Hello again, everyone. My name is Arief. I'm a machine learning engineer at Gojek Singapore, where my daily works are deploying and scaling machine learning across organizations. Not just data science, but also engineering team can also deploy their model. So we can democratize machine learning across organizations and help business drive decisions by data and machine learning power application. Without further ado, let's start with my presentation. Today I'm going to talk about making machine learning model deployment magical with Merlin. What is Merlin and what is machine learning model deployment and what is the challenge? Uh, what is the challenge that make machine learning model deployment hard? Before that, I want to confirm that you guys can see my full screen. Can you, Melissa? Can you confirm that? Hello, hello. Can you guys see my screen?
Yeah, yeah,
Can
Mas. I
someone?
can see your
Okay.
screen now.
Okay, cool. I will continue. Let's talk a little bit about machine learning. So I'm not going to tell you about the definition of machine learning because I believe there's a lot of speakers here that talk about machine learning. Then I will show you the real life example because sometimes it's easier to show you what it looks like so you can grasp the power of machine learning. So in Gojek, like you may know if you are Indonesian, I believe all of you already know about Gojek. Gojek is ride-hailing application, so you can order ojek or car or ride or GoFood and then you can get away with it. So in Gojek, we use machine learning to allocate driver and also the customer. This is the allocation problem, and also this is the heart of our system, and it's really critical for us to get it right. This allocation problem is hard problem. It's supply and demand problem, and we also need to think about not only we can provide driver for go ride, but also some customer want to order go food and then also order GoSend. So we need to know the match, the supply between that. And here we are using machine learning that called Jaeger. You can googling it, and you can googling Gojek Medium Jaeger. So we use like rule-based component, rule-based machine learning here. And the benefit of this is we have more efficient allocation and we can save million of order per week after we deploy this. The second example that we believe almost all of us already know is food recommendations. It's basically system recommendation, but it's recommend you the food that you might like. And the way it works is it look your historical order if you have, and then try to match it with the similar people. Like let's say you have ordered bread, and then uh, the people around you also order bread and also order maybe noodles, then you will get noodle as your recommendations. This we have a collaborative filtering recommendation and also content-based recommendation here. And then I also have one example that I have built during our pandemic. It's basically the face mask detection where we can detect if we use masks or not. And I use a TensorFlow to build it, and I deployed into web app, and you can check it in my GitHub website. This is the link below. Next, I hope that little introduction about machine learning example in real life can give you introduction about machine learning. Now to talk about how we deploy, how we get machine learning into production, and how our customer can get the benefit of it. Um, in machine learning, in machine learning life cycle, it also share the similar process like data mining and any software life cycle. Like if you know software engineering, you start with business understanding, with requirement and gathering, and then object oriented analysis and designs. You spec the PRD and etc. In machine learning and also in another process of data mining, you share the similar process. First, you start with business understanding. You need to know why you need it, what is the problem you want to solve, what is the pain that the customer faces, and what's the benefit will be get if we solve this issue. Now next you need to check whether you already have the data that can support your decisions. You need to understand whether this is just the pattern, whether this is just anomaly, or you can see this is where your data analysis or BI analysis can help you to understand this. Next, you have data preparations. You have data, but it doesn't stop there. You need to have data to be prepared. And some company have their own solution like data warehouse, data lake in BigQuery, or in Microsoft it use another Microsoft BI tools. In Amazon they also have something like that. They're similar, like I forgot what it's called. And some company also in Gojek itself, we have data engineering team that prepare the data across the company using Kafka for streaming process. So if the data scientist can stream the data, can take a look at the data, they can just connect to Kafka topic. And also Kafka also beneficial because it's uh, it can be used for data analytic for real life application. So the application, the mobile app or the backend can just stream the data, can just publish the data into the Kafka, and then we have a data warehouse that store the data. It's like cold data storage that we use Kafka as the input. Next, the modeling. This is where our data scientist friend do what he does best. Uh, from the data, he train his model, and then uh, it uh, it it keep training the model until it gain the operation that we want to have. Then they also evaluate the model. If they believe that this is already fine, it will deploy into productions, and then they can iterate to understand what is the improvement that can be made. And today we will focus our talk in deployment part, this yellow green box, because deployment is it's look easier, but it's kind of tricky, and I will tell you about the challenge about machine learning model deployment in the next slide. Yeah, this is the problem that we want to talk about. So data scientists have their pre-trained ML model. What's next? For all of you that doesn't know about pre-trained ML model, it's simpler to tell uh, to understand it like this is the artifact of the machine learning model. So pre-trained ML model is the set of output, the set of rules that from our training, which is it could be the model of like neural network, another CNN or anything else, and then it packaged into artifact, and then we can load that model to make the prediction or to make the inference. So the data scientists already have that ML model artifacts, and we need to deploy it. So this is the ML model deployment challenge. The first challenge is it's entirely different tools and workflow. Data scientists familiar with Python and work mostly in Jupyter, and also they use another ML framework like TensorFlow from Google, PyTorch from Facebook, or Skylon and XGBoost. And they also use Pandas to for their data transformation, and they work mostly on Jupyter Notebook. This is their development environment, but it will be really different when you deploy it into uh, to what you call it to productions, because the production environment doesn't have Jupyter. It also you can use Jupyter to deploy your model. In production, you may want to have something like virtual machines that have your Python install and that you have your web service there. Or in this cloud native era, you want to have Kubernetes that can wrap your model into Docker and then deploy it, and then you can scale it. And that kind of engineering task is really hard, and data scientists can do that by themselves, and they requires engineering support. Other than I introduce you about that deployment pipeline. Deployment pipeline basically the pipeline that data scientists needs to have to get their model into productions. And not it's not ended that, they also need to monitor, alert, and operate in it. Let's talk about a little bit about this deployment pipeline. First, the data scientists do their model training. They have their training code, like I said before, it could be in TensorFlow or Python, etc. And they also have data sets. So their training code will pull the data from the data set. It could be BigQuery or maybe just PostgreSQL database. They do the model training, and then they have the pre-trained models. Next, they want to have this model to be served into the productions. Um, to do that, they need to have their serving code. There's two kind of serving code. Uh, it could be there's two way to serving the model. Uh, the first one is by separated into the applications. So let's say you have the mobile application like Gojek, right? And you don't want to load your model artifacts into the Android package or iOS package, because the size of APK download will be so huge, and the user don't want to download your update if you have your model artifact. So the things that you can do is you have your applications you have your mobile application, and then you have your mobile application call a web service that have your model and also have that serving logic. That serving code is the one that loads your model, and then when it's received the request, it call the model, it do the inference, and then it return it to the applications, to your mobile application. That's the first way how to do the model serving, uh, by separating it, by deploying the model as the web service. Or the second way is just like you can package your model, you can bundle your model artifact into your application, your system. Like I said before, you can have your model inside of your mobile applications, but the drawback of this is your application package will be so huge. And then in this model serving, in this green area, you have your model uh, uploaded into production and served in the productions. So the challenge of this is you need to have your serving application, serving code to be low latency. It means it fast, highly available. So it if it's have the issue, it can respond themselves. And then next, they have monitoring. Like you need to know the request, the number of requests coming to your model. Like then you need to also know about the CPU usage, memory usage, and etc. Next, it will be really nice to have if you have the alerting. So if something goes wrong with your model, you don't need the customer to tell you about it. You will be the first one that know about the problem, and then you can minimize the risks. The next one is easy redeployments. This is redeployments here. It's mean like you need to be able to reiterate between your applications, between your model versions. So like I said before, data scientists need to evaluate their model performance and then make the improvement of it and redeploy it with the newer version. This is really hard to do, especially for data scientists that doesn't have a lot of engineering support. And there's a lot of questions and unknown here, like how you get it deploy, how you get it safely deploy, what is the security as well, and how to achieve highly available, and how to be cost efficient. This lead to longer time to market. There's a famous tweet from Gina Blaber. There's a famous story in machine learning. It took data scientists 3 weeks to develop their models, but it may need 11 or more months to get it deployed in productions. And we will in Gojek, uh, we uh, we depends on machine learning to make a smart decision, to make smart applications. And after we introduce Merlin, we successfully deploy integrate machine learning. So it will so after we introduce Merlin to Gojek, data scientists can deploy their machine learning model in less than 10 minutes. And I will introducing you about Merlin. Merlin is an open source project by Gojek. It's it's make deployment of machine learning model easier by following these design goals. Before that, uh, you can check our GitHub about Merlin. Next, this is the design goals of Merlin. We believe that machine learning model deployment should be first, it should be self-serve. It means that data scientists should be the one that can debug it, can also deploy it, and they don't need to have high entry to barrier. They can just getting started with machine learning modeling as easier as they starting the develop their model. So we have first class support for Python and Jupyter Notebook first experience. So it means that data scientists can deploy their Jupyter Notebook from, uh, sorry, it means that data scientists can deploy machine learning model from their Jupyter Notebook. And also we have the UI. So this is the fancy UI that can help data scientists see the model that they already deploy. And it should be fast. It should be less than 10 minutes from a pre-trained model to be deployed as a web service endpoint. This will allow for a fast iterations. Next, we believe that it should be scalable. It means low overhead. It can manage high throughput and able to handle huge traffic loads. So if there's spike, let's say you have the spikes of the request to your application and also the request to your machine learning model, the deploy machine learning should be the deploy model should be able to scale itself. Next, we have cost efficient features. We believe that in this cloud native era, machine learning that got deployed from Merlin should be able to automatically scale down. So it will minimize the cost. It means like so the example is, let's say in the daytime we get 100,000 requests per second, but in the evening or in the midnight the requests come down into the half of it, like maybe 50k requests. After we know that the request is scaled down, the request is decreased, we also want to reduce the replicas of the model. We want to reduce the workload of machine learning model, because if we reduce the machine learning model, we save the infrastructure, we save the virtual machines, we save the money of that infrastructure. To achieve that, we introduced these 5 features of Merlin. The first one is standard model deployment. Merlin supports deploying widely used models such as TensorFlow, PyTorch, sklearn, and XGBoost. So if your data scientists have TensorFlow self model.pb, it can just give the Merlin that URL, that model, that artifacts, and Merlin will deploy it. It also supports the deployment of arbitrary Python code. Let's say your data scientists have different logic for implementing the model. Maybe they have feature engineering that need to be done before calling the infer function from your model. Then you can use this Python defined model. You can also control the traffic to your model using traffic management. So you can introduce new model versions But let's say you're not sure about this model version performance, so you want to only send 1% traffic to it, then you can use it from Merlin. Next, you can have batch prediction job. Uh, um, for the first three feature is for real-time model serving, but Merlin also support offline model serving like using batch predictions, and we able to have transformations from BigQuery to BigQuery. So Merlin will connect to your source and then retrieve the data and then do the batch behind the scene, and that batch become the input for your model. Next, we have monitoring and logging out of the box. So it will have the data scientist observe and make sure that if something goes wrong with their model. This is how we deploy standard model using Merlin. First, you import Merlin. Before you import it, of course, you need to install it. You can install it from pip. So pip install Merlin SDK, and then you just import Merlin. Next, you need to define this model type. Next, you set the URL. This is basically the Merlin server where you will communicate between your Python code or your Jupyter notebook to the Merlin server. And next, you set the project name. Let's say the project is PyCon demo. Next, you set the model name and also the model type. In this example, I set the model name to be iris classifier. This is to classify iris flower, and the model type is TensorFlow. After that, you can do the model training and then have your model artifact saved in the model dir path here. So you can just call Merlin new model versions, and then you ask Merlin to log the model. This is basically upload your model artifact into Merlin storage. And next, you ask Merlin to deploy that model. After the deployment finish, Merlin will return you the endpoint URL. And next, you can just call that URL for predictions. All right. Uh, for serialized model, like I said before, other than TensorFlow, you can also upload XGBoost. You can specify where is your booster pretend model, your job for sklearn, and your PTH for PyTorch. Similar to deploying user-defined model, but the difference is instead of logging your pretend model, we log your Python code. Here you define class that implementing Merlin Python model, and this class must implement infer functions. So it receives the request, and then you can do anything that you want with the request. Let's say you can load the TensorFlow model by yourself from here as well, and do some data transformation. And then after you finish, you can just return the request. Next, you upload artifact your artifact including dependency requirements. So you need to upload your echo models and also environment YAML. This is conda environment YAML, like you specify the dependency, what is the Python versions, what is the library that you may need for your Python model. Maybe you need NumPy there, then you need to specify it here. Then you can just call Merlin deploy, and it will build Docker image for you and deploy it for you. The third feature is traffic management. Like I said before, after you have your model deploy, you can set the traffic to be sent to that model by certain amounts. Let's say this is the first model, and when we call Merlin deploy, it will generate model 1 project and the URL. And next, you can call generate model endpoint, and it will send the 100% traffic to that URL. The fourth feature is running batch prediction job. It's similar with what we have in Python, but here we need to implement Python version 2 model. Here we need to implement initialize and infer functions, in initialize, you can load your job, you can load your model artifacts. In the infer function, you can do the prediction. You can do the prediction from the model input, which is the pandas data frame. This is the input that prepared by Merlin for you to have your model to do the batch predictions. Next, you specify the source of your BigQuery. Let's say for this example, the table is this one, your Google Cloud Project, datasets, and Merlin Iris. The features, which is the column, and then the sync, what is the target, the output destination for your prediction job. And you need to have your service account here so it can connect to the BigQuery. Right now, Merlin only supports a batch prediction from BigQuery to BigQuery, but we are planning to support Google Cloud Storage in the next iterations, and also support another traditional database like Postgres or MySQL. And we also thinking about adding the support for another cloud solution like from Azure and also AWS. And finally, you submit the job by calling create prediction job, and you pass the job config parameter. Next, we have observability. We use Grafana to display the model performance. So you can see here, this is the request volume, how many requests per second, and what is the latency, the average 99 percentile, what is the error rate, and you can also see the CPU usage, memory usage, and etc. And oh yeah, this similar with previous one. And this is the UI of the Merlin. You can see the model versions for your model. In this screenshot, I have a sample project here that have Escalon sample model, and I have 10 version of Escalon sample, and I have deployed the last version of Escalon sample, and here I get the endpoint. And now I can just call the endpoint here. Right, under the hood, Merlin is Merlin's built by considering the next cloud native solution, which is on top of Kubernetes. So you need to deploy Merlin server to your Kubernetes, and then you need to expose the Merlin server to get the URL. Now, then your data scientist can connect to Merlin server from any kind of Python environment, whether it's Jupyter Notebook or from Visual Studio Code Python extension or from Conda, etc. And when the data scientists deploy the model from Jupyter Notebook, Merlin will use MLflow for model storage and model version management. MLflow is another open source project. This is also awesome that help tracking the model version easily. Next, when the data scientists call deploy functions, Merlin will wrap that model into key app serving specifications, and it will get deployed by key app serving as a knative service. And then when it's deployed by knative service, it will have that auto scale feature. They also have the endpoint URL, and now you can just call the endpoint from your model. All right, next I'm going to give you the demo of Merlin. First, I already prepared it here. Let me clear all output first and make sure I got connected to VPN. Yep. Okay. First, oh yeah. Before that, let me tell you about what are we going to do. So we are going to deploy Iris classifier model. Basically, this model will classify whether the input is which type of iris, whether this is versicolor, setosa, or virginica. and it will take a look at 4 features. It will take a look at sepal width, sepal length, and petal width and petal length. All right, we are going to deploy the we are going to train the Arief classifier using sklearn model. First, we need to install the requirements. You need to install Merlin SDK and scikit-learn and joblib. And next, you need to import the necessary libraries. Next, you need to set the Merlin server. This is the Merlin application that already deployed, and it will be the one that we keep interacting with, and also give us the demo like this. So we can see the project here, and we can see the models here and model version here. So first you need to install the Merlin, and after you get Merlin installed, you can use this URL as the Merlin server URL. All right. Next, you set the active project. You specify what is the project name. What is your machine learning project? It could be like allocation project, pull recommendation project, or etc. In this example, we are going to use PyCon demo as the name. Oops. All right. We are connected to Merlin server, and also we already set the project here. And next, you specify your model name and also model type. In this example, I will rename it into Iris classifier. The model name would be any kind of name that you can use to label your model. Like it's for
Mr.
example
Arief,
for
sorry for
yes.
interrupting your talks.
Mm-hmm.
I'm sorry for interrupting your talk. Can you zoom the text so
Oh,
it's
sure.
going to be bigger for the audience because it's too small.
Sure. Yeah. How about
Okay,
it now? Is it better?
okay,
Okay, I
it's
can
better.
zoom a little bit.
Okay, thank you, Mas Arief.
Cool. Thank you, Melissa. Got it. Okay, so after you specify the project, you specify the model name. This similar like if you can name your model by anything you want. It could be it's similar with class in programming language. And when you have your model, you can lock your model and it will become model versions. I will tell you about it later. So here, you can also check this notebook in the in GitHub in examples. Let me zoom as well. So you can take a look at the example here. All right, let's get back to my Jupyter notebook. So each model also has a type, like I said before, it could be sklearn, TensorFlow, XGBoost, etc. And next you have model versions. Model version represent a snapshot of particular model iteration. So let's say after you train your model with the new data, you want to have new model version. And let's say you have you change your parameter and maybe you use your previously you didn't use hyperparameter and then you introduce it and you want to log it for another new model versions. Right now, let's create a new model first. By calling merlin.setModel iris classifier, we will have new model here. Oops. Yeah, we also have this authentication Google. So we have iris classifier here, and we still don't have versions because we haven't logged any model. We haven't trained our model and we haven't uploaded the new model here. So let's get back to our Jupyter notebook and let's train the model first. Here we are going to train the model so it able to classify the iris type. Um, First, this is the Escalon library that we are using, and we also use data sets load iris. This is from, if I'm not mistaken, this is from Escalon as well. So we use Escalon data sets built-in load iris. This is the data sets. Yeah, this is basically all the iris data that we can use, and we split it into iris data and then iris target. This is for data training, and then we start the data training. We start the model training, and then we save the model. We dump it into the serialized model here. Here we finish the data training. You can see here we have model job lib here. Next, we want to lock that model. We want to upload that serialized model, that pre-trained model to Merlin. We log it by calling new model versions. It will create new model versions, and then it also upload the model here. And we specify the model directory, which is this Escalon model here. Let's do it. All right, let's check here. Here we see the ML flow, the new version of our model versions. And we can also see the ML flow link. This is the model storage that Merlin use, so it can help you see what is the artifacts, which is this is we only upload model job lib here. Next, we want to deploy the model. So after we get this, we already locked the model, but we want to deploy it. To deploy it, you can use Merlin SDK by calling deploy function, or you can use the UI here. Let me show you the UI first. So here you need to specify the environments, which is the Kubernetes cluster target where the model will get deployed. In this demo, I use Minikube for this. Minikube is Minikube is the smallest version of Kubernetes, if I can say. So it's really helpful for us to getting started with Kubernetes in local development. Next, you can specify the resource of your model, like how many CPU that it may need. Let's say, for example, I think 25 mega is enough. The memory, the RAM, it will be needed, and replicas. Replicas is how to say it, yeah. It's like the workloads of your model. If you specify one replica, you will only have one workload of your model. So it means like if you have 100 requests to your model, it will just be handled by this one workload. But if you increase the replica into two, it means that you have two models running at the same time, and it can share the load of the request. And Merlin can specify what is the minimum replica and then what is the maximum replica. So let's say your model receive a lot of traffic, it can scale into 5 replicas automatically. And let's say in the midnight where there's no request anymore, it will scale down into 1. So this is the cloud native features that we have in Merlin thanks to Knative, by integrating to Knative. Okay. You can click deploy here, but I will get back to Jupyter Notebook here. So data scientists can, when they iterate with the model and they want to try the model in calling the model, they can just using their Jupyter Notebook and call Merlin deploy here. And we start deploying the model into Merlin. And let's wait for it. When it's finished, it will give us the endpoint URL, and then we can call that endpoint URL. Let me display you what is the URL gonna look like. Okay. All right. When that you can also see if the status of the deployment. So it's still pending because Merlin is still deploying it. All right. Previously it was success. Hopefully it's success again. All right. Let's see behind the scene. Oops. Yep. Okay, it access now. It take, I think it's, yeah, I believe it less than 10 minutes to get it deployed. So that's how Merlin deploy the model, and it returned the endpoint URL here. So the engineer or your applications, your web service can call this URL and it will generate the predictions. So let's try to call this URL using this, and it return predictions for this input is 2 it's mean, sorry, let me explain what is this. So the instance, the request payload is like this. It send the features of the iris that we want to classify, and it's basically they send to instances of iris to be classified. And if we see it here, it means that the first instance, the first input have label 2. Label 2 is mean, I forget what is this. So it's mean the iris label, iris type 2. And the second one is also iris type 2. Let's try another example. Maybe what is the iris for this kind of iris? I don't think this is X. Yeah. So this is the iris type 1. If you see the iris with sepal with 0.1, sepal width and sepal length 0.1, as well as petal length 0.1, it's have higher probability to be iris type 0, which is the versicolor. All right, and here you can see the status of your model is already running, and you can also see the logging here. So you can see the log for your model. So we send the 2 requests here, and if there's something wrong with your model, you can see the log here. Let's say for this example, we don't send, we send invalid input. It will return for 0, 400. This is basically bad request, and we can see the log here. Okay, that's the demo for one more. You can also safely redeploy your model. Let's say, oh, we need to add another replicas, then you can just increase it, or say you need more memory, you can just modify it here, and then you can redeploy it here, and Merlin will get it redeployed. And during that time, you still can have this endpoint to be called because the deployment happened gracefully. All right, I think that's all from the demo. We have 10 minutes left. So for the final slide, I want to say thank you, terima kasih, and special thanks to my team that includes Arya, Roman, Theo, Jingying, Susu, Yusi, and Willem, and data science platform team at Gojek. Next, what you can do is you can check Merlin on GitHub, or you can also check Merlin on Medium. I forget to put it here. So you can just you can just type in Google Gojek Medium Merlin, and you will have our blog introduction about Merlin. And you can always connect with me on my Twitter and GitHub at Arief R23 and Arief Rahmansyah. Thank you. questions, everybody?
Okay, thank you for the amazing talks, Mas Arief. And there are questions here
Mhm.
from the Feodora Felicia Claire Fidelavia
Okay.
Punai. Does the URL given by Merlin fluctuate when we modify our existing model and redeploy it?
All right. Next question. To answer it, I will demo it to you. So let's. I'm going to share my screen again. Let's say you. Okay. We already have one version of our iris classifier, right? And here we have this URL, and we can always call this URL using this curl, like this. Okay. Mm, it's the oh not that one. Sorry. I'm going to open terminal here. Okay, so this is the URL. Oops, my bad. Sorry. So we have this model version endpoint, right? We can send it, and then why it's wait, yeah, strange. Oh, okay, wrong URL. I think I copy wrong URL there. All right. Okay, this is the first model endpoint URL, and we can deploy another version of our scalars. We can just call this again, and then we deploy it again. We will have different URL for this. Please wait for it. And during that time, sorry, what's the question again? Yep. All right. The answer is no. The short answer is no. But I want to show you, to demo you behind the scene and how you can achieve power of uh, the power of Merlin that can make you safely iterate with your model versions. So when we redeploy our model, like I demoed it before, when we click redeploy, we will still have this URL. This URL will become the obsolete, and it can be mix match with another versions. But then you can give this URL to your engineering team, like, hey, this is the URL for my model version, for my model solutions, and you can call it. But it will be not possible to keep asking them changing the URL if you have new model version, right? Let's say, um, let's wait for it to be finished. After this model version 2 deployment finish, we will have new endpoint, which is iris classifier 2. So this is basically the new URL, and you can just give it to your engineering team. But you don't want to keep asking them changing that. That's where we introduce this traffic management feature, right? All right, we see here we already have iris classifier 2 here. So iris classifier 2 is similar with the previous one. Yep, but this is just for demo purpose, but in your case it will be the better version of your model, and then it return also the same predictions. Let's say you already give the engineering team here, and you say that, hey, I have this new version and this is the new URL, and your engineering team asks, can you just give me one URL, and then whenever you have your new model, you can switch it by yourself. And here where we introduce serving. This is basically the traffic management that uh, I introduced in my slides, but I didn't tell you in the demo. So I will demo it right now. So we serve when we have this start serving, we will have the new URL. This new URL will be constant and will never change. And you as a data scientist can decide which model the traffic will get routed to. So in this example, let's say, oh, all right. I think this is the misconfiguration in my uh, in my version of Merlin. But the idea is when you click the start serving here, you will have the new URL, the iris classifier URL here, and you can just use that endpoint, and you can select which version to be served. So it's similar to with what I have here. So you can just call set traffic, and then the new version will be the one that receives the traffic. All right, I hope it's answer your question. I'm sorry that the demo is not run as I expected. Okay, back to you, Melissa.
Okay, thank you for the answers, Mr. Arief Rahmansyah. Yeah, maybe that is the last question for our session today because
Okay.
we are running too late for
Yep.
going to the next session. So thank you so much, Mr. Arief
Okay.
Rahmansyah, for
If you
the
guys still have question,
thoughts.
feel free. If you guys still have question, feel free to reach me at Twitter at ariefr23, and you can see my profile in PyCon website. Thank you, Melissa. Thank
Okay,
you all.
thank you so much, Mr. Arief Rahmansyah. Thank you for
Thank you,
all the
Melissa.
participants.
Bye bye.
Bye, guys. We can next to the session like we talk.